And as always, we begin with factoring. Now, it could be that sometimes you get something like this and it doesn't factor. If it feels like it's not factoring, you could use the quadratic formula to check. And that quadratic formula would help you solve the x-intercepts. This one does factor. If it's going to be negative 2x squared, it's going to be negative 2x and x. And negative 2 will be negative 2 and 1. If I put the negative 2 there and the 1 there, you multiply it out and check, it does work. Now our non-permissible value, x can't equal 1, and because it doesn't cancel out, that tells you have a vertical asymptote at x equals 1. And because the degree is bigger in your numerator and nothing simplified, this is a situation where we're going to have an oblique asymptote. You find your oblique asymptote with either synthetic division or long division. In this situation, you can use synthetic division. We're dividing by x minus 1, so we put a positive 1 out there. Your coefficients are negative 2, positive 5, and negative 2. Bring down the negative 2, multiply, add, multiply, add. And your oblique asymptote is negative 2x plus 3. You can find your y-intercept easily by plugging in 0 for x. Probably easiest to use the original equation. Negative 2 over negative 1 is 2. And your x-intercepts you can find easily from the factored form. What would make the top equal to 0 would be 1/2 and positive 2. So we'll have 1/2 comma 0 and 2 comma 0. Question? Let's see. Yes, it's supposed to be positive. But the remainder, probably why I didn't check it, because the remainder does not matter in synthetic division for an oblique asymptote. The remainder could be anything. When finding the equation of your oblique asymptote, it's just what you're left with. But thank you, that was a mental math mistake. And at this point, we can start our graph. What do we know? We can do our asymptotes. We're going to have an asymptote at x equals 1. That's our vertical asymptote. And we're going to have an asymptote at negative 2x plus 3. A reminder, how do you graph y equals mx plus b? You can start with your y-intercept. Then the value in front of x is your slope. A slope of negative 2 means I go down 2 over 1, down 2 over 1. And we have our oblique asymptote. Label all of our intercepts. So we have 0, 2. 1/2, 0. And 2, 0. So in this section where we have 2 points, we can draw our graph towards the asymptotes. And something that's sometimes confusing, right, is that you're wondering if I have enough points in all of the sections. You do, because it's only a vertical asymptote that separates your domain into 2 sections. So we have a point when we had 2 points when x was less than 1. We do have a point when x is bigger than 1. So we have enough information to draw that towards the asymptotes. No extra points are needed. I find, especially with the oblique asymptote, that sometimes people get an E10 error. An E10 error is an asymptote error. I'm going to make one here in purple. Okay? I find people have no problem getting close to vertical asymptotes. They're good at that. But for whatever reason, when going to this one here, this often happens. Right at the end, you swoop away from the asymptote. Every time you swoop away from the asymptote, that's an E10 error, because an asymptote is there that the graph just keeps getting closer and closer and closer to it. So it's considered a misunderstanding if your graph swoops away, right? And if you say, oh, I knew that, then it's just, well, you weren't careful. And you lose the half a mark for either not being careful or for misunderstanding it. So if your graph swoops away from an asymptote, that's an E10 error and a half a mark deduction. Okay, I'm going to give you some time to do the 4 questions on number 5. If you finish all 4 of them, here's a challenge question with a weird parabolic asymptote. I'll never give you one like this on the test, but if you want to try one that has an asymptote that's a parabola, you can.